my next piece of advice is keep it simple, sweetheart. And similar to the problem solving, troubleshooting, debugging advice I gave before, when you're given a problem by your professor, you have to be able to break it down into simplified steps, whether it's homework or quiz or whatever. What are the steps to get from point A to point B? What formulas do I need? What theory do I need? I will use Lilybot again as an example. I designed Lilybot in my head during my 1-hour commute to work. This is the final result of Lilybot, but this isn't where I started. Once I decided I wanted to design her, I had to come up with the steps. So the first thing I knew was I had to design the chassis. What did I want the chassis to look like? I had to design where the sensors were going to go on Lily. Then I had to make the bottom chassis, where the battery was going to go. So I broke it down like that. Then I had to figure out what kind of battery pack we were going to have. Then we have standoffs for Lily so that I could connect the top and bottom chassis. And then I know I needed wheels, motors, and caster wheels so that Lily would be stable to move around. And then the last stage, which is what you're going to see this weekend when I get it all coded up, is I had to have motor and sensor mounts so that I could attach those to Lily. And once I have her sensors, the final step is I need to wire Lily up using my breadboard and my wires. And then I need to attach Lily's brain, which in this case is going to be a Mega or Uno. And I made a whole robot, but I didn't walk out the door with a robot. I had to start with step 1, go to Tinkercad and make the 3D models. Step 2, make a good model that we could then 3D print. And because this is an iterative process, we had a couple of bad designs that I had to chuck and start over because the engineering design process is iterative. So KISS, keep it simple, sweetheart. Take that complicated problem and break it down into steps. Deuces and stay STEM-tastic.